The chemical processes of major importance today are those involving the addition of polymers, surfactants, or caustic to the injected water. In a polymer flood, a long-chained molecule called a polymer is added to the injected water. Because polymers are expensive, we normally inject only a slug of polymer solution, shown here in purple, which is pushed through the formation from behind by conventional water injection. The polymer increases the viscosity of the water, thereby improving the mobility ratio and increasing the recovery efficiency. The primary benefit of polymer flooding is in the improvement of the aerial and vertical sweep efficiencies and the acceleration of oil production. Our second chemical process involves the addition of surface active agents, or surfactants, to the injected water. A good example of a surfactant is the soap we use every day to clean our hands. These compounds can act to reduce the interfacial tension between the oil and water in the reservoir, reduce the residual oil saturation, and improve the displacement efficiency. Surfactants are usually introduced to a water flood as components in a water-oil surfactant, or micellar solution. A slug of this solution, shown here in yellow, is injected into the reservoir at the leading edge of a flood. A polymer solution is usually injected after the micellar solution to control the slug and improve volumetric sweep efficiency. The polymer solution, in turn, is followed by normal water injection. The injected fluids push an oil bank ahead of them and leave a relatively low residual oil saturation behind. In the case of caustic flooding, sodium hydroxide, added to injection water, reacts with certain crude oils at the crude-water interface, forming surfactants in situ, shown here in brown. This reduces the interfacial tension and thus the residual oil saturation. The heavier, more viscous crudes are usually the most responsive to caustic flooding.